Let's look at Chiefmate's MCA Stability Examination, December 2016, question number 2. It says, a vessel is floating at an even keel draft of 8.8 meters in salt water, kg 7.50 meters. A midship rectangular deck 25 meters long and extending the full breadth of the vessel is flooded with salt water to a depth of 0.50 meters. Height of deck above keel 11.75 meters. Using the stability data booklet, calculate each of the following. A. The fluid GM. B. The angle of Loll. We will first draw the figure. So the vessel, this is the transverse section of the vessel. This is the length of the vessel. This is the deck which has been filled up with water. This is the water which has been filled up, and this is the length of the deck where water has been filled up. The center of gravity of the vessel has been given as 7.5 meters. The height of deck from keel has been given as 11.75 meters. 0.50 meters is the depth of water on the deck. The length of the deck in which water is filled is given as 25 meters. And the draft of the vessel is given as 8.80 meters. We'll first calculate the mass of water filled. So this is the basic geometric calculation, which is the length of tank times breadth of tank times the depth of tank multiplied by the relative density of liquid inside it. The length of the tank is 25 meters, which is this value. The breadth of the tank is 20.42 meters, and this has been derived from the stability data booklet because it says that the width of the tank extends the full breadth of the vessel. The depth is 0.50 meters, which is this value, and the relative density of salt water is 1.025. So when we solve this, we get mass of water filled as 261.6 tons. The next step is to determine the kg of the liquid on the deck. To determine the kg of liquid on the deck, we apply the formula kg of deck plus half the depth of the tank. Since the water has been filled up till this level, so at around half its height, we will be having its center of gravity. We know the height from keel up till the deck, which is 11.75 meters, and we know the height of water which has been filled on the deck. So the small g, so distance from the keel to small g would be the kg of the deck plus half the height of water which has been filled up inside the tank, which is kg of the deck plus half the depth of tank. So kg of deck was 11.75 meters, which was given in the question, and half the depth of the tank is half of 0.50 meters. So kg of water filled is 12 meters. The third thing which we need to now calculate is the free surface moments which has been induced because of the water on deck. So free surface moment for a box shaped compartment is calculated by length times breadth cube divided by 12 multiplied by density of liquid in the tank. The length of the tank is 25 meters, which is this value. The breadth of the tank is 20.42 meters, which has been derived from the stability data booklet, and it is extending up to the full width of the vessel. The density of liquid inside the tank is 1.025. and it is divided by 12. So the associated free surface moments is 18182.3 tons meter. Now we'll make a kg table which has the following columns, which is number 1 description, number 2 weight in tons, number 3 kg in meters, number 4 vertical moments in tons meter. We had our initial value, the weight of which is 18,843 tons, which has been derived from the stability data booklet against the draft of 8.80 meters, because the draft of 8.80 meters was given in the question. Kg is 7.5 meters, this was given in the question. So we'll obtain its associated vertical moments by multiplying these two figures. The second thing we'll add is the deck water, which we have calculated it as 261.6 tons and its kg as 12 meters. So when we multiply these two values, we will get associated vertical moments. This weight of deck water has been obtained from this part, and the kg of this deck water has been obtained from this part. Now, since there is free surface moments has arisen because of the deck water, and free surface moments are supposed to be taken into consideration when we are calculating the final kg of the vessel, so it has to be put in the kg table. So free surface moment because of deck water is 18182.3, which has been obtained from this part. So the total value, so the total weight is 19104.6 tons, which is sum of all these values, and the total vertical moments is 162,644, which is sum of all these three values. Final kg is given by sum of all the vertical moments divided by sum of all the weights, which is 162,644 divided by 19104.6, which gives us the final kg as 8.513 meters. Now we will obtain km final. So km will be obtained against the new displacement, which is 19104.6 tons, and it will be obtained from the stability data booklet by doing interpolation against this displacement. So the km which was obtained was found out to be 8.471 meters. The kg final was obtained as 8.513 meters, which was obtained from this part. So the gm final would be km minus kg, which will give us minus 0.042 meters. So the GM final is minus 0.042 meters. This is the answer for A part. The B part asks us to calculate the angle of Loll. Before calculating angle of Loll, we need to calculate BM transverse. With the new displacement of 19104.6 tons, we will again enter the stability data booklet and obtain the value of KB by doing the interpolation. So the value of KB has been obtained as 4.674 meters. And BM final, what we will obtain is KM final minus the KB final. So the KM final value, we had obtained it initially, which was 8.471 meters, which was obtained from the hydrostatic data booklet against this displacement, and KB final was also obtained from the hydrostatic data booklet against the new displacement and was 4.674 meters. So BM final is 8.471 meters minus 4.674 meters, which gave us the final value of BM as 3.797 meters. We'll now calculate tan of angle of Loll, which is given by the formula under root of minus 2 times GM divided by BM transverse. When we put in the values for GM, we'll put minus 0.042 meters, which was obtained from here, and BM transverse was calculated as 3.797 meters, and it was from this part. So tan of angle of Loll will be given as 0.14874, and angle of Loll will be equals to tan inverse of 0.14874. So angle of Loll would be 8.5 degrees, which can be on either side because it can either go to port or it can either go to starboard.